Hello, this is Rand Woodward recording for Lab 1, Part 6 of Intel's Digital Logic course through FPGA Academy. And in this part, we needed to extend the functionality of the previous part where we had DE10 scrolling across 4 7-segment displays. And in this example, we have to use all 7-segment displays and watch DE10 kind of scroll across all 7-segment displays. And there's 6 of them. And because there is 6, and rather than using switches, we can't have because we don't have enough switches. We had to actually code some constants in here, and so that's some of the bigger changes. Let me go to the mux here to show. So we have where we declare these as constant values, and depending on what they are, we'll see that switch out. The mux will send out what value that is, be it A, B, C, D, E, or F. And all of those will correspond to a certain character. In the decoder, I have those set here. And so we will receive the input here, that 3-bit input now. And rather than having a 2-bit input, as we can see, we have 3 bits. And that's so that we can actually have all the necessary selections, because we could only have the 4 if we were doing 2-bit. And with 3, we're allowed to do much more. So with 3-bit, we can do 0, 0, 0 for D, 0, 0, 1 for E, 0, 1, 0 for 1, then 0, 1, 1 for 0, and then rather than doing blank, I elected to have a little dash character, and that's just so it's easier to see the DE10 kind of scrolling across those 7-segment displays. But those are the cases that this BCD decoder will handle, and it will show DE10 dash dash on all 6 7-segment displays to start, and then as you toggle the switches, it's basically incrementing them in binary. If you increment the switches 1, 2, 3, 4, so on, you'll watch that DE10 move from left to right across the 7-segment displays. Okay, in the primary file, this Lab 1 Part 6 file in VHDL, I ended up removing the declarations to the inputs, the switches here. As we can see for our mux component, we have switch A to F, but I don't have that in the port, and I discovered that it was quite difficult to actually get that to work, to declare the constants in this lab VHDL file as well as in the mux. So I removed those and everything worked fine. It was basically just doing some shuffling around just to get it to do the same thing. And rather than having them declared as switches, this means that I needed to have these as hard-coded values. And I haven't tested this, but I'm assuming that because of these values here, we actually don't need to declare these values in the mux here. I've not tested it, but I have a guess that because I have them hard-coded here, we wouldn't need them in this mux file here. But I'm not sure on that. I haven't tested it. And aside that, we just basically we add a few more usages of that same structure from the previous lab, where we have, switch 9 to 8, 7 to 6, 5 to 4, 3 to 2, 2 to 1, or 1 to 0, etc. And then we have our selector switches, which we define up here, and there's 3 of those. And then we have our intermediate signals here, M0 to M5. And those get passed out to the hex displays, hex 0 to hex 5, as defined up in here in the Lab 1 Part 6 ports. It's not much more different than the previous part, but we just had to extend it, and we had to use constants rather than a bunch of switches that we used as input. And here is the Verilog portion of this. And again, it was just as easy to go from VHDL to Verilog again, as we saw that I needed to remove those ports. The switch imports, so those values are hard-coded here rather than having them actually be inputs to the circuit, and those intermediate signals are getting passed to the hex displays here. And that's it. Verilog is a lot more succinct, and that's why it's a lot more easier to go from VHDL to Verilog in my opinion. Alright, but I'm going to add a little tutorial, or demo rather, to the end of this, and you'll... Alright, and here is Lab 1 Part 6. We can see our DE10 and the 2 dashes on all 6 7-segment displays. I put 2 dashes rather than leaving them blank, just so it's easier to see that the word is rotating. We have our selector switches, and these other switches don't do anything, as we saw in the code. There are constants. And so what we can do to move them is actually just increment these, essentially treat this as a 3-bit binary number, and we can watch this move from left to right. And so if we were to hit, it's currently at 0, so we can type 1. We'll watch the D move to this last space here. If we flip to 2, it'll move to the next one. If we go to 3, it'll move over. And then if we move to 4, it'll move here. And then finally, it'll move to 5 if we go there. So I'll try and do that a little accelerated. So we do 1, 2, 3, 4, and 5. All right, and that's it.